Good day, students. How are you doing? This is me again, Sir Navarro, and welcome to our tutorial video. So in this video, you will be able to learn about the, um, the implications of the changes in the values of A, H, and K in the graph of a quadratic function if it's in the vertex form. Alright. So this might be divided into two parts of the video since this will be a long, lengthy one. Alright. So now let's proceed. So we begin with the effects of the changes of A in the graph of this function f of x equal to ax squared. Alright. So now let's proceed. Consider the parent function f of x equal to x squared. So if we are to graph this one, please take note this is actually f of x equal to x squared. Alright, so if you are to solve these values of x to get y, then you have to substitute it here. So negative 3 squared, that's basically 9. So all the values here will be just squared, right? So negative 2 square, negative 1 square, then 0 square, 1 square, that is just 1, and 2 square, also 4, 3 square, that's also 9. So after that, after obtaining these values, you now locate these points. So first we have negative 3, 9, that's 1, and then negative 2, 4, negative 1, positive 1, then the vertex 0, 0, and then 2, 1, 1, 2, 4, and then 3, 9, right? And then this goes on and on. So if you are to graph this one, this will be the image, or this will be the graph. So this parent function will be used with the other implications later. So to begin with, consider these functions, two functions, g of x equal to 2x squared and h of x equal to 1/2 x squared. So we always consider that y equal the vertex of the y function y equal to ax squared is vertex. The vertex is 0, 0. All right. So now we have to solve these values. Consider the function 2x squared. So to solve this, we have to square negative 3 and then times by 2. So that's 18. The same thing, square then times by 2, 8. Then square, that's 2. 0 square is 2. 0 square is 0 times 2, that's 0 again. 1 square is 1 times 2, and this goes on. So to solve for the other one also, we have negative 3 square times 1/2, that's basically 4.5. Negative 2 squared, that's 4 times 1/2, that's 2, and so on. So you can verify these values using your calculator if you have any, or if you want to verify. So moving on, we now graph this function in comparing to the graph of the parent function, this one, y equal to x squared, right? So to graph this one, we need to locate these points. The negative 3, 18 is here, negative 2, 8, and negative 1, 2, 0, 0, and then 1, 2, 2, 8, 3, 18, somewhere here. Then connect. So this is the graph of the function g. And then let's now graph the graph of the function of the h function. So these are the points. So negative 3, 5 is located. Negative 3, 4.5, 3, then 4.5 is here. So it's between 4 and 5 in the y. So 3, 4.5, negative 2, 2, it's here. And negative 1.5, so it's somewhere here. And 0, 0. So you're just going to reflect these points on the other side. This one, and then this one here. So now you have established the graph. So the question is, how does A affect the graph of the function y equal to x squared, ax squared, or f of x equal to ax squared? How does the changes in A affects the graph? Alright. So what are the implications? So what can you observe with the graph? So you have noticed when A earlier, when our A is for the blue graph, our function is g of x equal to 2x squared, right? So if you have noticed, it's much closer to the y-axis, or it's getting what the word is? It's getting narrow. What about the orange one, or the h, the function? We have 1/2 x squared. So as the value of a is 1/2, what can you say about the graph of the h function? It's from the, compared to the black one, it's widening. All right, the graph is widening. Okay, so to speak, what can we infer? The same goes with when we have negative, all right, negative functions. Okay, when we have negative function, it goes like this also. So to speak, it means that the effects of a, of the function in the function f of x equal to ax squared. Of course, we know that if a is greater than 0, that means it's positive, it opens upward. If a is less than 0, it opens downward. Aside from that, we can also say that if the coefficient a in f of x equal to ax squared makes the graph narrower or wider compared to the parent function, which is a behavior we call stretching. All right. So it means that if the earlier, if you notice the value of a is 2, makes the graph narrow towards the y-axis, right? So meaning to say, when the absolute value of a, all right, is greater than 1, so it can be 2, 3, 4, 5, 6, and so on, it will just keep on getting closer to the y-axis compared to the graph of the parent function y equal to x squared. But if the function, the coefficient a is less than 1, meaning to say it's negative, the graph of the parabola is wider, all right? So it goes like this, compared to the graph of y equal to x squared. So what does it mean? So let's go to this one. So here I have a what's this? A graph in the GeoGebra. So if we try the values going to the 0, it's getting wide and wide and wide and wide and wide, all right? Wider pa jud. But if we're going to go to the negative, the same way, if it's getting too far, it's getting narrow. But if it's getting closer to 0, it's getting wider. So it's the same way with positive or negative. So it runs around on that figure, all right? So to move it, where is it? All right, so let's proceed to another implication. So another. Now let's proceed to the effects on the changes of k in the function f of x equal to x squared plus k. So to begin, we're going to use the same function, all right? So the same parent function, this one. So we already graphed that one. So let's proceed. So we're going to use these three functions. So to solve these values, you can actually use your what's that, calculator. So we have here -3, so the value here will be -3 squared plus 4. -3 squared is 9 plus 4, so that's basically 13. And then this one, -2 squared is 4 plus 4, 8. -1, so 1 plus 4, that's 5, and so on. Then to go for the other one, we have -3 squared plus 2, that's 9 plus 2, 11. -2 squared plus 2, so 4, 6, and so on. And this one, we have -3 squared minus 3, that's 9 minus 3, that's 6. -2 squared minus 3, that's 4 minus 3, that's 1, and so on. So to graph this one, we compare its graph to the parent function, which is the y equal to x squared. So now let's graph. -3, 13, it's somewhere here, this one. Then negative 2, 8, that's negative 2, 8, that's here. Negative 1, 5, it's here. 0, 4, it's here. 1, 5, it's here. 2, 8, it's here. And 3, 13 is here. Next function. So negative 3, 11, it's here. Down here. And then negative 2, 6. Negative 1, 3. 0, 2. 1, 3. 2, 6. And then 3, 11. Alright, so proceed. We have 6, 1, negative 2, negative 3, negative 6, negative 2. So negative 3, 6 is here. Negative 3, 6 down here. Negative 2, 1 down here. Negative 1, 2. Negative 1, negative 2 is here. 0, negative 3 is here. And just reflect on the other side. There. So my next question is, how does the changes in k in the function f of x equal to x squared plus k affect the graph of this parent function g of x equal to x squared? So how does it affect? What does the k implies? What does it do to the function? So then, do they have the same do they have the same shape with the graph? Of course, it's a parabola, but what I meant is, do they have the same widening or the narrow or the same wideness of the graph? Of course, they will have the same because our a here is 1. But the question is, what does k implies for? So if you notice from the original graph here, so, and then we're going to graph the first one going back to the orange one. What did we do to graph it? Like this one. So, like for example, this function. This is the parent function, right? X squared, y equal to x squared. So, what did k do here to graph the orange? So, let's try to locate the vertex here, and then you use the k value, which is 4. K positive, so let's try to count going upwards. So 1, 2, 3, 4. And then this point, 1, 2, 3, 4. This point, 1, 2, 3, 4. Meaning to say that k there is the movement of, same way with the others, it is the movement of the values of the graph along the y-axis. If you notice that, for example, this one, if we have our k as 2, so k is 1 plus 2, so since it's positive, you're going up. So 1, 2, same with this 1, 2, 1, 2. Same with minus. For example, this one, negative 3, so 1, 2, 3, so the vertex will be here. And then this point, 1, 2, 3, it's down here. Since it's negative, so you're going to count downwards. So yeah, that's it. So the implication of k is, if k is positive, then the graph is shifted upwards k units. Alright, k units. Okay. If k is negative, so absolute value. If k is negative, the graph is shifted. The graph of it's lacking here, but it's referring to the graph of y equal to x squared. Alright, so it's shifted downwards k units. So absolute value k units. Meaning to say that k there is the movement along the y-axis. If k is positive, you need to count many k units up. And then if k is negative, you need to count k units down. From the parent function y equal to x squared. Alright?